Very good morning, students. Today we are going to learn applications of matrices and determinants. So in this chapter, first let us learn what is the matrix definition. So the arrangement of numbers or elements in a particular order in rows and columns. So if we are arranging an element, let us suppose 1 to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I have arranged these elements in the rows as well as in the columns. So this arrangement is nothing but matrix. So today we are going to learn what are the applications related to matrices, means in what cases this matrices we can use, and the determinants. So let us start with the first concept. So before learning this, first let us understand what is a square matrix. A matrix in which the order will be n by n. A matrix whose order is n by n. It may be 2 by 2 matrix or 3 by 3 matrix or 4 by 4 matrix, whatever the order might be, but the same number of rows and same number of columns must be there. That type of matrix we are going to call it as a square matrix. So this is about the square matrix. For example, we can see 1, 2, minus 4, minus 3. Any of the elements we can take. So this is called a square matrix. Why? Because there are 2 rows and 2 columns. Since it is a 2 by 2 order matrix, we can call this as a square matrix. Now, in this square matrix, we will find the determinant. So what is the meaning of determinant? Let us discuss. First, let us take a matrix A, 1, 2, minus 2, 3, minus 7. So if I am asking to find the determinant of A is equal to modulus of, this is A, B, C, D. So formula will be AD minus B. So AD minus B means A into D minus 7 and minus B into C minus 6. So modulus of minus 7 plus 6. So the answer is modulus of 1, which is not equal to 0. Since I am getting not equal to 0, then I can call it as a non-singular matrix. Non-singular matrix. If I am getting the determinant is equal to 0, then I have to call it as a singular matrix. Singular matrix. Now, here two important things. When the determinant answer is equals to 0, we have to call it as a singular matrix. If it is not equals to 0, we have to call it as a non-singular matrix. Now, let us learn a new topic based on this. Adjoint of a matrix. So what is the meaning of this adjoint of a matrix? Let us see. So this is totally based on the term cofactors. Cofactors of matrix. So if I define the cofactor as m, then it will be a I j. That is minus 1 whole power of I plus j. So by this formula I can define the m. M means minus of a matrix. So element, it means minus is an element of a matrix. So minus 1 I plus j. I indicates rows, j indicates columns, Aij means a particular matrix. Now, if I want to mention the adjoint of a particular matrix, then I have to make, if I want to write adjoint, then let us suppose a matrix A is there. So for this A11, A12, A13, A21, A22, A23, A31, A32, A33. So it is a 3 by 3 square matrix we have taken. So in order to make this matrix as an adjoint matrix, so first of all we have to make it as the minus cofactors. The cofactors are, so let me write here, cofactor matrix which is m1 1 1, M 1 2, M 1 3, M 1 4, 1 5, 1 6, 1. Sorry, here it is 2 1, 2 2, 2 3, 3 1, 3 2, and 3 2. After writing the minor elements, if the sum is even, if the sum of these rows and columns is even, it will be plus. If it is odd, it will be minus. So it is minus. Here also minus. Here also minus. Here minus. Okay, remaining are plus. And for this cofactor matrix, this is cofactor matrix. So if I want to get this now adjoint of matrix A is nothing but we have to write the cofactor matrix. For that we have to do transpose. That is M11 minus M12, M13, M21, 22, 23, 31, 32, 33. So here the addition is odd. So wherever the addition of the rows and columns is odd, we are mentioning it with minus. Why? Because we are using a formula as minus 1 whole power I plus j. So I plus j means if power is even, it will be plus. If power is odd, it will be minus. That's what we are mentioning here. So transpose. What is the meaning of transpose? Means changing the rows into columns. So whatever the first row is there, it will become first column. Second row, it will become second column. Third row, it will become third column. So it can be written as M11, M12, M13. Next second, M21, M22, minus M23. Here M31, minus M32, M32. So this is the formula. Now, what is the final definition of the adjoint matrix? Adjoint matrix will have the rule. So, A into adjoint of A is equal to adjoint of A into A is equal to modulus of A into I. So, this is also one of the properties. Next, let us take example 1.1. If A is equals to 8 minus 62, if the divided square matrix, we need to prove adjoint A into A is equals to A into adjoint A is equals to modulus of A into I. Now, to prove that, first let us find out the data. Adjoint. So, adjoint of A is equals to. So this first one, 7 is 21. So first, if I want 8 cofactor is I have to delete this row and this column. So this column and this row, if I want to delete 7 is 21, 16. 21 minus 16. Next, here it will be actually the minus symbol is there, but I have to delete this row and this column. 6 is 18. So minus 18 plus 4 to the 8. Next, in order to get these two values, 2 cofactor, so 6 4 the 24 and 7 to the 14, 24 minus 14, all of transpose. So next, in order to get this minus 6 value, I have to delete this row and this column. So 6 3 is 18 minus 8, 18 plus 8, minus is a minus plus. Next, in order to get this 7 value, I need to delete this row and this column. So 8 is 24 minus 4. Next, in order to get minus 4 value, I need to delete this minus 4 row and minus 4 column. So what are the left elements here? 8, 4, 6, 2. So 8 4s are 32, which is minus 32. 18 minus this formula. 8 4s are 32. Here minus is a minus plus. It will be 6 to the 12. Next, we are left with here 2. So 2, this row and this one, that will be 6 4 the 24 minus 14. Next, we need to delete this minus 4 row and column. So the left terms are equal to minus 32, 6 to the 12, plus 12. The last one, 3 here, third row and column, 7 into 56, minus 6 into 36. So the 21 minus 6, 5, here 10. Here 10, but before writing this value, let us write the symbols of this here. Minus, already I have discussed here. Minus is here also minus, here minus, and here also minus. So why? Because third row, second column, the sum is minus it will become, and here second row, first row, second column, and first row, third column it will be sum is addition. So here second row, third column, and second row, first column will be. Here second row, first column will be addition is odd number, so minus symbol will be. So here 5, here 10, here also 10. So here minus 18 plus 8. Minus 18, sorry, it is minus 18. So minus 18 plus 8, it will be 10. So here 20, here also 20. And 24 minus 14, it is 10, and yes 20, there are 20. So this is the obtained matrix without transfer. Now if I apply the transformation, I get to change rows and columns, that is 5, 10, 10, 10, 20, 20, 10, 20, 20. So this is the obtained matrix of adjoint A. Now, for this adjoint A, I need to multiply with A matrix. So for this adjoint A, make sure I need to multiply with A matrix. Let us see. So A into adjoint A matrix. So that is A matrix is 5, 10, 10, 10, 20, 20, 10, 20, 20 into A matrix. A matrix is the given matrix which is 8 minus 6 2, 8 minus 6 2, minus 6, 7, minus 4, 2 minus 4 3. So this is the multiplication of the matrix. So if I multiply these two, if I multiply these two matrices, then what we are going to obtain here? 5 into 8, 40, 10 into 6, minus 60, plus 10 into 2, 20. So like this, if we let me write next 5 into 6, minus 30, 10 into 7, plus 70, 10 into 4, minus 40. We have to take here first row, first column, first row, second column, first row, third column, like this. So 5 into 2, 10, 10 into 4, minus 40, 10 into 3, plus 30. And next the second row, 10 into 8, 80, minus 60, 20 into 6 is 120, minus 120, plus 40. Minus 60, 27 is 140, plus minus 80, and 10 to the 20, 24 the 80, and 23 is 60. 10, 8, 80, 26, 120, and 22, 40. So since there are 10 numbers, we are going to change minus 60 plus 140 minus 80, 20 minus 80 plus 60. So if I do simplification of these, I am going to get obtain a matrix name. So 80 plus 40 will be 0, 0, 0. So I am going to obtain a 0 matrix. Null matrix we are going to obtain, which is equal to 0 into modulus of IT. Means it is an identity matrix in which principal diagonal elements are equal. So it is called as 0 matrix. Now which is equal to 0 into I3. Now why we are writing 0 into I3? I will tell you. Afterwards we have multiplied here A into adjoint A. Adjoint A into A we have multiplied. Next we need to multiply 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3 into 5 10 10 10 20 20 10 20 20. If I multiply these two matrices, even though I am going to get 0 0 0 0 0 0 0 0 0, which is equal to 0 into I. So by this I have confirmed that now let me find out first mod A value. After getting the mod A value, we will get what type of it is. So let us find out the determinant mod A. Mod A is nothing but here what are the next let us learn about inverse of a matrix. So what is the inverse of a matrix means? Whenever modulus matrix is not equal to 0, then inverse exists. Inverse exists. So just now we have said that modulus A means determinant value if it is not equal to 0, then inverse is going to exist. So what kind of matrix is going to exist? We can call it as non-singular matrix. We can directly call it as non-singular matrix. It means if modulus A is equal to 0, we will call it as singular matrix. If it is not equal to 0, we will call it as non-singular matrix. So for every non-singular matrix, inverse of a matrix is going to exist. So A inverse is given as 1 by determinant of A into adjoint of A. This is the formula for A inverse. So A inverse equals to 1 by